Good evening, this is Rahul, and I'm going to present six webinar on our QL for patient-oriented medical record series. This presentation is based on the evidence-based clinical case reports under the supervision of Dr. Sabah Mohammed and Dr. Jinan Fiaidhi. So, as a part of this presentation, we cover a general overview why case report is important in medicine, what is our current workflow, what is PICO wrapper, what is the search strategy, and how we are building the query to fetch the article from the PubMed data site. And then we also go through the architecture of our system. So, as a in this project, we consume the some of eutils library from the PubMed data sites, and this project is built upon this Sangria Scala framework. Neo4j database we use to store our data, and we use GraphQL, and for the UI side we use Angular framework. So first of all, why case report is important? Because uh, today's we have lots of data and lots of articles which is uh, done on different patients conditions on different disease. So it will help us to recognize new and very rare disease, and also give us idea about the therapeutic effects and different interventions, and also give important role in evaluation of the intervention, and it is also improving the problem based medical education. So in our EBM workflow, first we build the PICO query. We ask a provider or physicians to give some basic context, or what he or she wants to find is a part of the PICO framework, and then we extract the search terms and then build the search strategy, and with help of the search strategy we build one query, and we use this query into the PubMed data set and find the articles, and then summarize that scraped articles and finding the answer with this help of significant data. So first of all, what is PICO element? Ideally, PICO element stands for patient or problem. It is indirectly referred to the subjective section of the SOAP note. It could be symptoms, diagnosis, or concern that the patient has reported. For example, patient having the overweight, so we call obsessed patient for that. Intervention, it is the referring to the objective section of the SOAP. It could be medication, procedure, or any therapeutic measurement. And C for the comparison, it is the optional section of this query, but let's suppose let a physician wants to find any alternative intervention or treatment, then this section is very useful for that. Yes. Now outcome is nothing but like what would be the ideal desired outcome or goal for the intervention. For in case of obsessed patient, we can say they decrease the weight of the patient. Okay, so for example, if a SOAP note describes the patient with cough and fever who was diagnosed with pneumonia and started on antibiotic, so PICO element could be patient with pneumonia symptoms we consider as a patient or problem. In the intervention, we can say that antibiotic treatment. For comparison, we are looking for any alternative treatment options to improve the situation or condition of the patient, and the outcome is nothing but improvement in the pneumonia symptoms. So basically this is the basic representation of PICO wrapper in our Neo4j database. If you see there, here highlighted is the patient PICO node, which includes all the things like comparison, intervention, outcome, problem, and time period. And this is the SOAP elements like a subject objective node, which describe the uh, case of the patient. Now we have PICO elements. Now first thing we need to find the search terms, which we divide that terms into two different categories. One is mesh heading terms and another one is the general keyword. To consider which term is mesh heading terms, first we need to split the sentences or questions into the keywords. So here we use NLP library to generate different keywords. For example, in a patient is school age children or child, then we use the NLP to make sure that the word is in very base form, and then we generate the keyword with help of ngram concept, language modeling concept. So in that case, the possible keywords are school, age, child, school age, or school age child. In the same form, like reader, any decrease the or reader any incidence childhood obesity. So it will be generated in this form of keyword. And once we have this keyword, then we find this particular keyword in the PubMed dictionary, whether this keyword can be considered as a mesh heading terms or not. So once we have the keyword list, then we categorize into different sections: PubMed, uh, heading keywords, and another one is normal keywords. So subject heading keyword is more tightly coupled with the medical terms. It will give us more relevant information what we are looking for, the PubMed database sites, and it is uh, we can say that there are other synonyms for the same keywords, so that we have to check in the database, and for that we use the PubMed dictionary for that. So for example, if we say pediatrics in the Australia is different spelling as we use pediatrics in the US. So because of this variation, we have to use the PubMed keyword, which help us to consider this kind of scenarios. Now comes to the keyword, those keywords which are not PubMed keywords. Sometimes it is very important when we have like so many informations and we want to like uh, uh, filter out those information. In that case, this keyword is very important, and we also make sure that this keyword will give too much irrelevant information. For example, if we consider the like child patient, so in that case it will give all the research which is happening in particular that child patient who is a child, right? So in the so we have to make sure that like mesh keyword is also over there, so that it will filter out those records. Once we have keywords and the mesh heading, then we can build a query to fetch the articles. So to build the query, we have to consider three different operators. The first one is OR operators. When we want to find the result which contain any of the keywords, in that time we should go for the OR keyword. When we want to find the result which contain both the keyword, obsess with the asthma, right? So in that case we should go for the obsess and asthma. So it will give the all the results where the patient condition is obsess as well as the asthma. Now a tricks keyword, this is also very important keywords, because if you want to deal with the very large variation of the spelling of the same word, then we can go for these keywords as I mentioned here. Epsilons and epsilons are like basic word, so we can use that tricks at the end of this end of this word. So ideally, let's suppose from the P section of PICO framework, we find the three keywords P1, P2, P3. Then we join with the OR condition because we want the articles which might have P1 or P2 or P3. Now, for the let's suppose for the intervention, we have like I1, I2. For comparison, we have C1, C2, and outcome we have a O1, three different keywords. So all the keyword will in the section wise it will join with the OR, and all the section will join with the AND. So this is the basic concept when we build the search query. Once we have the search query, then we find the uh, articles of that particular query. So for that, we use PubMed database, and PubMed database have one programming utility we call as Entrance, where we can fetch the articles through the programming. But before that, there will be two parameters which you need to consider. One is API key, another one is email. Otherwise, after certain requests, the request is getting blocked by the NCBI portal because of some securities concern. So first we need to register ourselves in the account and get the API key and email, and we pass this API key and email on each request. So to fetch the articles, we have to fire certain. We have to follow some steps. First, we need to fetch the total number of records for the given query, and then we have to fetch some additional parameters to cache our query at the PubMed database. So that in our next query, every time PubMed database does not require to parse the query and the fetch the records. It just to use the pagination and give us record, which makes our query more and more faster. So for that, we have to first register our query to the PubMed database side, and it will give us the one query key and web environment. So with help of these two parameters, we load the articles on page wise, and those at the same time we store those articles in the Neo4j database as a new node and create on relation with the PICO node. So this is our architecture query language for POMR. So here we see that like we have a user interface which is directly connected with the GraphQL server, and GraphQL server is connected with backend application Scala, which utilize another components. One is the preprocessor, which help us to find the possible keywords from our PICO query, and it is also connected with the PubMed utils, which help us to fetch the mesh terms as well as the script as well as the articles which is related to the query, and it is also connected with the Neo4j database to store our data. So here, if we go with the component wise, we use user interface. In the At the user interface side, we use Angular and Bootstrap framework to design our view part, and we use GraphQL query language that is allow us to specify the data what we are as per our requirement and more efficient than the our traditional REST API. And to support GraphQL in Scala, we use the Sangria framework. As I mentioned earlier, like we use the Scala for our backend application, and there is a reason because it is like a scalable, it is scalable and type safety language, and performance is quite good compared to other languages. And in the Scala, in the backend applications to achieve our functionalities, we use a HTTP server to handle our web request and standard NLP library to process our text. So preprocessor is nothing but the small utility which process the PICO questions and generate the possible keywords from the user questions. Now PubMed utils, it is like a one kind of web service which is provided by NC, National Library of Medicine, that allows the developer to access the PubMed programmatically. And the Neo4j database is NoSQL database, which help us to store some complex interconnected data, like we have articles, and it give us a schema. The free data model allows to repeat the development and iteration. So this is the basic main components which we use to develop our application. Now this is our UI, where you see here uh, there are two buttons, like to add new patient or add new soap for particular patient here, and this is the list of soap, and there will be three button. One is the soap, where we can see the soap sections, and another one is PICO. It will be look like this way. Yeah, here it is a free text where user can enter the questions and click on the submit button. Once PICO query is saved, then we click on the search button to fetch the articles. So once we click on the search button, it will generate the query like this way, which we can save with the save query button, or we can add it. This is the again open text editor, so user can, if user want to mention any extra keyword, then you can mention here. And when we click on the load articles, then we, with help of this query, system goes to the PubMed database side and fetch the articles, and this is the listed article connected with this PICO query. So this is the basic UI for our QLM or POMR PICO wrapper. Now let's take one case, like a patient with having type 2 diabetes and is facing the overweight. So a physician is treating patient with these conditions. So our PICO question would be like in the patient section, patient with type 2 diabetes who are overweight, or we can say obese, and intervention is like a patient uh, is preferring to low carbohydrate diet. So then comparison would be like is there any other possibility of diet that can help us to reduce the fat and high carbohydrate, and outcome would be primary outcome would be the diabetic control, as well as the reduce the weight and blood pressure. So ideally the question would be like patient with type 2 diabetes with overweight problem, does a low carbohydrate diet lead to better glycemic control compared to the standard diet over the period of 2 years, and what are the potential risks and benefit of this dietary intervention? So first of all, this is the case representation for this case, and this is the some symptoms we can say they like started in medicine that we already observe. And this is the PICO frameworks, where we can see the this is the uh, detail of this particular PICO questions, like such problem patient with type 2 diabetes who are overweight or obsessed, and this is the different sections: outcome, intervention, comparison, and type A. And this is the search query, with help of PICO elements we generate the search query for this particular patient. So once we load the article, so then it will our back node will look like this way, like it is PICO questions and it is connected all the related articles. So let's do, for example, the same condition with this patient. So currently this is the medication section. It is patient is taking up these medicines, and this is the basic vitals, lab results, and diagnosis data. And if we talk about the PICO sections, then this is the question which we mentioned earlier, like problem low carbohydrate diet. Ideally, we want to follow the low carbohydrate diet, and we try to find any alternative solution so that we can get low weight, or we can reduce the weight with help of and but condition is that like we have to absorb high carbohydrate, and this is our primary goal. So once we save this one, then when we click on the search button, then we'll be having this query like blood pressure, weight loss, blood pressure, diabetic, diet, research, and let's suppose yeah, if user want to modify the query, then he can add here like any keyword he want. And when we click on the load article, then it will fetch run this query into the PubMed database side and fetch the whatever articles which is related to this one, this query. So here if you see that like list of associated article will gets like association between fat-free mass, changes in appetite, weight gain in individual with obesity. So on this way we fetch the articles from the PubMed data. So and the basically the background in the database side it will look like this way. PICO node is connected with articles which is related to that particular PICO framework. Now let's consider the second case where the 33-year-old female having cough and dyspnea mechanic asthma bronchial. So our patient condition would be like symptoms of cough, dyspnea, and chest pain. While intervention is diagnosis testing, including CT tomography and the fiber optic bronchoscopy. If we talk about the like comparison, so we are looking for treatment options for particular this condition, and our outcome would be diagnosis of the inflammatory pseudo tumor of the lung. So our question would be from this case is that like what is the most effective treatment for accurating diagnostic inflammatory tumor of the lung patient who have like symptoms of cough, dyspnea, and chest pain. So again the case presentation will look like this way, where all the soft node is connected with particular patient, and that patient soft node is connected with the PICO here, and this is again the comparison like suggests the treatment option, intervention, outcome, problem, and the time period. And this is the again the one PICO node which is connected with the other articles in the database side. So if we go with our system, and let's suppose this is the second shop where like this is the basic conditions of the patient. What are the physical examination mechanism that is used by the physician, and this is the PICO questions which a provider or physician wants to give us like get the idea about any other treatment option is available for this condition patient with the symptoms of chest pain, and this is the current intervention, and what would be the like outcome we want for from the any treatment option. So when we click on the search button, so it will generate the query. If you see here like this is the basic condition of the patient, this is the intervention like diagnosis or lung, this is the any alternative query, alternative treatment they want or physician wants, So when we click on the query, then this query will save into the database. And when we click on the load articles, so it will fetch all the related articles of particular that query from the PubMed database and save it to our database. So if you see here, like a couple of articles which is related to the particular that query is displaying over here. Radiation therapy or city guided microlocalization. So on this way, physicians can find the related research papers for this condition. So this is a backend representation of particular case. Now, once this is our future continuation. Once we got the articles from the PubMed database side, so we use the BERT model, language model, to summarize each articles, and with help of this summarization, we use SOAP, patient conditions, and PICO questions to generate one case report. So if we talk about the future continuous, our future architecture. So here we introduce two different component. One is report generator and another one is BioBot summarizer. So BioBot summarize fetch the articles from the database side and you summarize each article, and then report generator will use this BioBot summarize to summarize the article, use the SOAP element, use the PICO queries, and generate one report, generate one case report for particular that question. So this is the references which I use as part of this prototype, and this two GitHub link is for the this project code. The first one is for the Scala backend code, and the last one is for the UI, which I use Angular as a content for it. So I push those code in the second GitHub link.